So let me just start by introducing myself. My name is Kobi Biton. I'm a specialist solution architect for strategic customers in AWS. I mainly work with customers on the DACH and Central Europe area. What I basically do, I'm about 8 years a solution architect focusing on independent software vendors, very large-scale setups. So before the Kubernetes era, application modernization, working with those customers to SaaSify their products, basically from perpetual licenses to SaaS models. And over the recent years, considered an expert in basically multi-tenancy, networking, and Kubernetes. What we will discuss today is I picked up about 6 or 7 decisions, which I call strategic decisions that my customers had to take throughout the journey of adopting a Kubernetes platform in general. Now, it doesn't matter whether it's AKS or GKE or EKS or just plain vanilla Kubernetes, the decisions will apply, highly likely will apply to most of the setups of a generic Kubernetes platform. And it's not going to be a 500 level deep session, although we can go there in the break if you want. It's going to be more for how to take those decisions, considerations, and what of my customers have shared with me throughout the journey. Where did they fail? What were the common pitfalls? And just discuss about those rather than just solve problems which are a little bit more complex. So that's about me. About 22 years in the industry, 10 years solution architect. I'm about a decade in AWS. I write quite a lot, so you can tune to the AWS blogs. I have few articles there, and I publish on my own website as well as devm.io, which is a platform for developers that I write constantly on application modernization, Kubernetes in scale. So people ask me what I do for a living. That's why I normally show them when I meet the customer or the partner for that particular sense. We try to be those who navigate things and not taking the front stick, if you wish, to drive this jet. The presentation today is quite simple. It will be a template of a graphic that I will present the challenge or the problems that my customers faced. And then we're going to discuss with questions on that I believe, and my customers, based on that experience, are paramount to answer before you actually take a decision. So kind of a technical analysis of the issue. And of course, I'm going to talk about patterns and anti-patterns and considerations where customer had common pitfalls or took decisions that impacted their technology strategy for their platforms. So let's start with the first. I would say, I think if I had $1 for every question I get from an ISV, I would be probably rich by now about multi-tenancy and running that inside Kubernetes. This is probably one of the most complex areas, especially for customers who are either migrating to a SaaS solution or hosting internal developer platforms, which is a little bit easier for the latter use case because these are considered trusted tenants, basically. So what's the challenge with Kubernetes in general and multi-tenancy? So I took, that's the first slide I show or a sketch when I start the chalk talk with the CTO. So CTOs don't necessarily understand how Kubernetes isolation model works. Kubernetes is great, but was never meant to be a multi-tenant product, right? It's a single tenant orchestrator, period. Whatever you try to tell your friends, it won't work. It's a single threaded. Yeah, there is the multi-cluster SIG, which is now working to try and fix that or adding controls. But the matter of fact is that in order to make it multi-tenant, the platform engineer team needs to work super hard to put controls and to anticipate attack vectors rather than just virtually just have a checkbox there that says deploy the Kubernetes in a multi-tenant fashion. So the first thing to mention is that the API servers and the control plane has a soft isolation. So all the processes there are shared across the entire data plane. And of course, on the worker nodes, namespaces are logical, right? So you can run out-of-the-box customers in namespaces, but they will still share, without specific controls, the same underlying compute primitives. And a container, it doesn't matter if you use containerd or Docker or whatnot, right? Run C. This is still a process-level isolation. In fact, I would argue with you that there's no such thing as a container. A container is an invented, from my perspective, term, because at the end of the day, it's kernel technologies. It's namespaces in kernel and some process restriction in seccomp. So we call it container for us to be very happy. But at the end of the day, it's a combination of kernel technologies that you try to isolate process, basically, and give that process multiple namespaces so the kernel will be able to allocate resources to it. So what are the common architecture patterns that I see out there? So I tend to see those three. It doesn't mean that this is an exhausted list of the patterns that I see there. And I try to divide them into three. You just saw the trusted model. The trusted model says that you might have an internal developer platform that you trust the folks there, or the application is considered trusted. So instead of spinning up a cluster per development environment or developers, you consider them trusted. And trust me, this is not your decision as platform engineers. You are, in that case, the planners and the executors. It's the CTO and the CISO which needs to define who is a trusted tenant. Once you set the strategy of tenants and isolation within your organization or with your customer, then you can go to the whiteboard and say, okay. And you will probably end up with multiple architectures at the same time. There's no good answer. It's not a 0-1. You might have tenants that you say, okay, I need to segregate them because they either pay more and they ask to be segregated. So that's a business reason to follow, that will follow a technical challenge in that sense. The trusted soft isolation says, okay, I'm willing to do a little bit of trade-off there, and maybe my developer platforms have characteristic of application that can cause noisy neighbor for certain applications that runs inside the container. So how do I mitigate that? So I just call that trusted soft isolation. And a trusted soft isolation means that you simply land applications in internal developer platform on specific nodes just for them. And what you do that with taints and tolerates and or basically selector, if you wish. That's a pretty good architecture to isolate for noisy neighbor, but that's about it, folks. Still, people who think that this is a decent isolation will be learned that I've seen a lot of attacks even using those patterns, because the Kubernetes pattern is a flat networking model pattern. So that you cannot take from Kubernetes. So still, networking-wise, this is a single unit of a flat network that front-end A can access front-end B. Of course, there are ways to make it harder for it, like network policies, but you get what I'm saying, right? You have to work super hard every day just to make sure that things will not connect to other things. And that's where the challenge starts. And then there is the third model, which we call it completely untrusted. This is an area where you know that your customers or your developers might run a code that will need privileges into the cluster, whether to mount host storage or to run as a privileged mode because you need to tinker and see the entire networking namespace. Trust me, there's no good way to protect that. When you define those as untrusted, the normal way to achieve utilization, cost effectiveness, and still have some kind of an isolation would be the solution in your application and not in the Kubernetes. Don't tempt to use untrusted for your tenants, because if you have 100 tenants, it means 100 clusters, and then that's going to be a nightmare. Challenge your software architecture, challenge your chief architecture to say, I want to understand what this UDF function does. Why can't I run it as a function, as a code in one of the cloud providers, right? Why can't I basically isolate that into a separate shared cluster between all the customers and do an async approach with SQS or any other queue system, Kafka, whatnot? what I learned through the years is that the chief architects will sometimes put the problem into your table as a platform engineer. Don't accept that. Ask the hard questions. Here is an example of a customer I work with. That's a classical example of a customer that just because he had an option inside his application for the users to run UDF functions that can create havoc on the underlying compute primitive in terms of security, we ended up doing that architecture. He started with Knative and then moved to Lambda because it was easier for him to manage. He didn't want to manage infrastructure, basically, but that's fine, fair enough. It depends really on your preferences here. What we see here is that the customer was still able to maintain a trusted model with customers in his SaaS service, but every time his SaaS service needed to execute something which is untrusted by his customers, that would be executed in a separated environment, very isolated environment, that if this environment was compromised, nothing would have happened in terms of leak of customer data, etc. That might have caused operational challenge there, yes, but you get what I'm saying, right? And the architecture can always also be asynchronic. You can have the result published into an object store and then consume that. So don't try to solve everything in Kubernetes. That's what I'm trying to say, right? Kubernetes is not the solution for your problems, right? It's a platform, it's an enabler, it's a means to achieve something. We have to look a little bit outside the microcosmos. I know it's hard, for me as well, but that's the reality. So what do you want to ask yourself when you are drawing or conclusions and you are in the midst of the architecture? The reason I've highlighted the top one is that I've seen, sometimes I ask the platform team, what is the application doing? What is the UDF function is doing? 90% of the time I get the answer, I have no idea. They just ask me to mount this volume and to do this. No. Your job is to say, I want to understand what the application is doing. We have to understand what the application is doing. We don't have to be an expert in the application. What is the tenant dimension? You need to ask the business. How would you define a tenant? Is it a service? Is it an application? Is it user? Urge the chief architect. How do you segregate tenants on the software level? Because this is the holy grail, to be honest. Tenants, at the end of the day, if a SaaS provider wants to make money, the segregation needs to go to the application level, which means that you should have a software dimension called tenant ID. You should have application authentication. And then the underlying infrastructure becomes just the vehicle for that. And cost-wise, per tenant, this is a great business outcome. But it can take years to get to just what I said here. So it's okay to have this hybrid model. But with the horizon and the North Star is to always yearn, if I develop a new service, that service the tenancy must be answered on the software architecture level as well. I've seen cases where customer think info was breached just because an application was able to access the Kubernetes API and to scan all the namespace names. It's weird, right? But if you use namespace name with customers, you just had a major breach, right? So use numbers for namespaces, not customer names, right? Yeah, but it happens. So what is the pattern and anti-pattern when you get to that design in this decision? Application level isolation, from my perspective, this is a very opinionated opinion here with Kobi. This is the holy grail for isolation. It doesn't mean that you don't need to apply other means on the underlying layer 4. Network policies, right? That's standard practice. Policy as a code engine, Kyverno or OPA, that protect in runtime, okay? So it means that if somehow your CI/CD pipeline didn't lint or your GitOps process didn't lint and something was able to infiltrate inside your onion approach, a container definition with root user, so this is the citadel that will protect you. Policy as a code would say, hey, I'm not allowing containers to run as root. But this is standard practice I don't have. There's a lot of people here in the crowd which know that 100 times better than I am. Don't disqualify cloud-based compute isolation. I'm not here to advocate that, But have a look at that. This might save you in a certain service for a certain period of time a lot of headache. Anti-pattern, try not to bring the old into the new. When I tell that, the first CTO answer would be, what is the old into the new? I get sick when I hear that the SaaS service wants to have customers VPN into pods. Don't do that, sorry. You can VPN to the pods, you can install OpenVPN in pods, but then you need to give the OpenVPN container a privilege that it can seize all the network namespace on the host, and that means that it can create havoc and tap into your customer's traffic. That's not how Kubernetes was designed, folks. If you do have those, challenge the software architecture. Why customers need to VPN? If they need to constantly connect to the environment, the use case is called platform as a service, PaaS. Then this is a completely different ballgame. If they need to connect because they need to submit data to it, that's a crime, sorry, quote, quote, that the software architectures are allowing that. No, there are hundreds of ways today, even not more, to pump data into your cluster. You can do it through object store authentication in the application and an asynchronous job that will do that. If you must do VPN in the interim, isolate that particular VPN part to a different cluster or not even Kubernetes, just to make the VPN call, some kind of a jump isolation VPC, and then from there, you isolate this risk inside your architecture. Questions here? Of course, we don't have to wait to the end of the session. By the way, I tend to talk a lot. I'll probably run over time, so you'll have to stop me at some point. How many clusters? Yes, please.
Hi. So the example, that graph particularly. So we had a use case where we had to separate two very sensitive data from two different clients. How would you go about, like, what would be your best recommendation on separating? So the API could be shared between them, but the actual data should be split across.
Yeah, we should talk about that on a coffee after the session, because I need to understand how your data classification works, whether you obfuscate the data. There's a lot of questions I need to ask as an architect. But basically, the same rules apply to segregation of data also in containers. If you store the data on an external storage, I would treat that as an untrusted tenant. The data itself, it's an untrusted tenant, right? And once you categorize it as an untrusted tenant, we need to see what is the isolation level that your underlying storage allows you to do that. So for example, in AWS, there is a way to isolate with NFS mount points through EFS, right? You can create a total isolation there, right? But with EBS, you can also do that, but it's going to be a nightmare if you do EBS isolation, because then you have to make sure that the EBS volumes will connect to the relevant tenants, and that's a major overhead. So we'll need to chat about on a coffee there, and to understand a little bit more how to use a storage, multi-tenant storage underlying system. It's not really Kubernetes, it's to understand which storage primitive that you're trying to use there, and definitely what controls do you put on the application in order to make sure that the data is being pulled, will not be pulled by other tenants. That's also another factor. This is the API part. How do you authenticate the data itself? Does it make sense? But we'll need to dive deep if you want, no problem, over a coffee. I'll be more than happy.
Sure, fair enough. Thank you very much.
Yeah, I have to continue here because probably I'm going to get kicked really soon. So, how many clusters? How many of you have needed to address that question, right? So, we can say what we want to say, but it's the new norm creating cluster, right? It's like Pringles, right? Kubernetes cluster, you start, you cannot finish. You have to finish the box. So, yeah, we need more clusters. We need to confine into and define the isolation boundary, because our services are becoming huge. I have customers who have 500 microservices, 2,000 containers, 5,000 containers in a single cluster. That's a huge blast radius. And they work really hard just to make sure that this huge blast radius will work. That's not good. We have to think about business dimensions on how we do that. Yeah, it's not easy because then you have to build another shared services platform. This could be a lot of implication. But so I can't give you all the answers here, but from my experience, I would just say, analyze your constraints, understand if you have untrusted tenants, organizational boundaries, and area of concerns. When you have this map, this multi-dimension map, start to think on how many clusters and what you segregate, what not. But with a single rule of thumb, optimized within constraints, fewer clusters, we've seen that, and this is data point driven, what I'm saying here. We've seen that customers who run fewer clusters are definitely more efficient in bin packing. That's because Kubernetes becomes the new server hardware in the data center, right? You have more, you are less efficient probably, generally speaking. So, create when you must, consolidate when you can. That's my 5 cents here. What is an anti-pattern to multi-cluster design, to number of clusters design, sorry. You didn't do any constraint analysis. You're just creating clusters because you want to isolate. A lack of deep day 2, day 3 challenges of Kubernetes. Day 3 comes, it becomes really complex. And moving tenants between cluster could be a daunting solution. That's why your planning should be. The holy grail should be, I will host, this is just an example, 15 tenants in a single cluster, which will yield 4 petabytes of storage, 5 applications. I'm going to reach to 200 containers. If you get to that dimension, you have a unit of deployment. That's great. Authentication, authorization, and encryption. Wow. A headache. You have your CISO in the morning, says, I want to do MTLS. You ask why, he doesn't have a good answer. He says, this is what we need to do. MTLS. Everybody's doing MTLS. We have to do MTLS. Wait. Ask questions. I'm not saying not. What do you want to do? This is what you want to achieve? If this is what you want to achieve, sometimes you end up this, right? And then the CISO is happy, but you're going to be very sad. Not because Istio is not a great product. The learning curve of a service mesh is immense. So just talk to the folks inside the organization. As a matter of fact, there's no very good solution outside service meshes today to manage a Paki and MTLS. I have to be very honest here with you. So try to challenge MTLS whenever you can, because this is an architecture that might solve you some problems. If you do need to do just encryption of pod to pod without clear identity on the application level, WireGuard, with Cilium will do a great job there, period. But the identity remains on the node and not on the application. So it really depends on how far you want to go with the identity in the authorization part. But on the other hand, going to a service mesh, that's gonna be a significant learning curve, only for that purpose. So don't just go for MTLS. Start with MTLS and service mesh, but understand the power, the things, and the other features that you might use as your cluster microservices get splitted more and more. That is, by the way, 10 minutes work. What you see here, right? 10 minutes, not more than that. So what do you want to ask yourself in the discussion with the CISO? What is my encryption requirements? Everybody says zero trust that day. What is a zero trust? What does it mean zero trust, right? That's very hard. Everybody will tell you a different answer if you ask them, right? MTLS is not zero trust. MTLS is a way to contribute to the overall strategy of zero trust, because in MTLS you do just mutual authentication of TLS certificates. So the client needs to authenticate and not accept, the server will not accept any certificate authority. That's the holy grail of MTLS. And service meshes were smart enough to connect that to the application level as identity. So that's the strong part of service meshes and MTLS. So they took that encryption level and also added the identity. Should you use your own public key infrastructure? Maybe. I have customers who use their own Paki for years, and this could be pretty good for MTLS as well. If you are able to use that, you don't have to go to the route of service meshes. So anti-pattern, evaluate service mesh just for the encryption requirements. That's, from my perspective, an anti-pattern. You can start there, But you need to have a very good plan to understand what else are you going to generate. Purpose-built container OSs. I call those just enough operation system to run containers. So when you go to any cloud providers or even your data center, you will need to address this question. What kind of an underlying OS? Now, most of you would say Ubuntu is great, I love it. But Ubuntu and even Amazon Linux are bloats, right? This is almost like the phone from Samsung, sorry, bloatware, right? It contains so many packages that you simply don't need for containers. And you're just enlarging the attack surface there. Now, we've done a lot of work in Amazon Linux too to minimize that and optimize, but still, it's a Linux distribution, folks. And what is the challenges with those traditional operating systems? Security, because you have a lot of things that you don't need on them, which you need to shave, as we call it in the SRE word. Updates, right? You can remain inconsistent with packages updates. We've seen that in the past. Overhead of management, and of course, drift, which is the worst thing. You don't know if you have, at any given time, a baseline there. So one example why container-built OS that started maybe with Core OS, if you wish, and Flatcar OS, those, and BattleRocket for AWS, and of course Google and Azure, here is an example of what BattleRocket can do as a container OS. Let's say that you have a pod that escaped, right? You have an attacker who escaped a pod, right? So you have a container escape scenario. It's a serious scenario, folks, and it can happen. And this attacker has an access now and is trying to maliciously load kernel module. A good container-built OS would say, sorry, you can't do that. I don't know this particular module. So you can't load this mood probe killer 1 module here. So this is just a glimpse on the tip of the iceberg of what container-built OSs can do better for you in terms of your security surface. But they only address the vertical attack vectors, right? Containers towards the host and not the lateral necessarily. So you're not solving your whole security issues with container OSs. And they will come with a price. They are very hard and very opinionated. If you have daemons that needs to run most of the time on those hosts, you won't be able to do that. So you can't run any workload that you can on them. But if you do happen to have this standard workload, basically, I would say that this should be your first choice of running, of OS to run. It doesn't matter if you do AWS, GK, I don't really care. I'm just saying explore those, right? Other areas, you have no package managers in .OSs. This is great, right? So there's no yum install or RPM minus, what was it? And they are smart enough, most of them, to say, okay, if you tinkered with the root file system, I'll just boot and brick the OS because something happened here that I shouldn't have happened. Or if you tweaked something in etcd, in /etc, you edited something, it will simply, after a boot, get back to the normal because it's a read-only file system, basically. So what question you want to ask yourself when you choose purpose-built, right? So I would just highlight one question due to the lack of time. Does your container OS provide support for OS outside the platform? This is super important. If you want to deploy it in your data centers or in other cloud providers, you just want to make sure that you choose one that you can get support from all the others when you deploy all the others. What is an anti-pattern to purpose-built container OS? I've seen customers sometimes try to tweak security policy to meet the container purpose-built OS or not. Don't do that. It's a security policy that drives architecture and not the opposite. Okay. So no, don't disable Linux in those, because if you disable Linux in a container purpose-built OS, so why do you need container? The Linux there is really to protect you. Yeah, I know it's a pain in the, we know where, but that's why it's there, right? To make it harder for people to attack. It's not a magic wand. People can still brick, but it will just be very hard for them to do that. One of the last decisions, sensible defaults without restriction developer productivity. It's a big sentence, right? But developers want to move fast. Platform teams are very cautious, right? How do you balance between those two crazy roles inside your organizations, right? So consider that common pattern. On the right side, you have the platform team. On the left side, application development teams. So they want to deploy something, an application, right? They get the whole integration pipeline that you as a platform engineers created for them. We're all happy. The folks on the platform team use Terraform, Crossplane, whatever, blueprints. You have a platform up and running. But then the developer says, hey, my application, you know what? It needs a database. I can't believe it. It needs an object store. It needs a DynamoDB table or an Aerospike table, right? How do you talk to that conflict? Who is going to deploy those resources? Are you going to give your developers technology such as ACK or Crossplane to do that? Or are you just going to do it as a platform team for them? Right? Well, what do you think, folks? Anyone can share his sad moments or happy moments about that? Yes, please. Go ahead. Okay. 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 That's a major, this is one of the biggest challenges I've seen with the customers I work with. So I'm not going to solve it here. I'm just going to tell you what I see customers doing and discussing, right? So one way, the platform team is going to do it for you, right? For your developer, right? But then you create this problem, waiting for the platform team, right? So if you don't have synchronized pipelines, this process will fail. You will simply deploy that, and that will come after that. So you have to create some kind of a mechanism to synchronize that particular part, right? If you choose the other approach, the developers that you put this strength in their hands, and it doesn't matter which technology, you give them Crossplane or you give them Argo, right, to do that, the platform teams might say, oh, wait a minute, there is a potential risk now. They're going to create like buckets like crazy here, and who knows which policies they're going to put that. So how do I? So you might want to have some kind of a controls here that understand that when that happens, you have some kind of a validation process that does it. It's very easy to do that. With pull request hooks, you can do quite a lot of interesting things. So just remember to make sure that you draw the demarcation point somewhere. And don't be too hard on developers. So if you have folks who understand a little bit infrastructure, you might have this hybrid model that particular developer group, you give them the option to do that because you know that they know what they do. For others, you might say, okay, not yet, right? So, and the last decision, and I will go it really fast because I think I'm out of time, multi-cluster connectivity. The holy grail, right? I have those hundreds clusters now. Let's do VPN with all the clusters. Wait. So they are the new norm, right? We talked about that. Isolation boundaries is one good reason to isolate. Risk mitigation, shared services architecture. No one wants his IDP wandering around in the customer workload, VPCs or clusters. Governance and cost domains, yeah, we have KubeCost and all the other great tools, but let's be honest, measuring in a cloud provider, not only AWS, all of them, traffic per tenant, it's going to be a nightmare. So sometimes you do need to isolate to get a cost domain. Not for all customers, maybe your biggest spenders, right? And of course, the rise of infrastructure as a code in GitOps made clusters a declaration point, right? Like objects. So people feel more, it's easier for them to create new clusters. But then you get this situation, right? Now you need to connect. How do you connect between those two environments? This is just a simple representation, right? And these are the challenges. Server-side discovery and interconnection, declarative. I would argue that the cloud load balancer integration with Kubernetes is probably the easiest way to start with. I'm not saying it's the best way to connect, but ingressing or service type load balancer for layer 4 cloud load balancers, it's probably the fastest way. So don't do paralysis analysis. If you need that, start there. It's pretty good. You can put a TLS certificate there, you can terminate, and then you need to think whether deploying hundreds of load balancers or tens of them is a cost-effective solution, and then you should put and challenge yourself, do I need to interconnect all of those? But that's a fairly good start, because server-side, they provide server-side discovery. You don't have to have any service discovery. I know it's weird, but you just need to know the endpoint of the load balancer, and the ingress will do all the magic for you. But then someone comes to you and says, hey, why not connect the two meshes together? Beware. That's not an easy task to do. I'm not saying don't do that. Service meshes do not span well across boundaries. They were never planned to span across boundaries, like Kubernetes. So before you run and force them to do so, like in an architecture of shared control plane with Istio, that's great, right? But if the control plane goes down, all your services cannot route in all clusters. So wait a minute, right? Wait a minute. We can chat about it in the break from experience I have with customers. I'm going to share, of course, the presentation after that, so you don't have to. And that's it, folks. That was my cue.